All right, so we need to pick up right on, I believe it was number 10, wasn't it? Okay. All right, so we're going to start right on 10 for you guys. Right there, perfect, thank you. All right, so on number 10, we've got another binomial expansion here. So you want to find the fourth term of 3x minus 2 raised to the power of 7. Oh, I'm sorry, I'll give you guys a second to get situated. Take your time. You're probably going to hear a lot of announcements because of the mock crash that's out in the front too. So they're probably going to come on the announcements quite a bit this period. They have all the emergency responders come. So you're going to hear a lot of sirens and whatnot. If they've done it like they do in the past. So we'll see. Yes, it's ball night. You didn't see the front circle? Oh, there's 2 cars crashed on the front circle for their simulation. Yep. Good luck on your way out. Yep. All right. So number 10, you need to find the fourth term. So the little shortcut on this is, what do we do with the 4? Exactly. Subtract 1. So you are going to subtract 1 off this. And again, I want to make sure I get to all your questions because this is your last day of review. So we've got 7, choose 3. Then I've got 3x raised. I don't know if you want a formula at this point or not. So technically you're going to do the 7 minus the 3. If you want to write that, you can. If you don't need to, I understand. So you could do that, or you could just jump right to this is 4. And then you're going to take your next term, which is the -2. And your exponents always have to add up to that 7. So this one is going to be a 3. So now you're going to do 7, choose 3. So math over to probability. And again, choice 3. Make sure you bring your calculators next week too. And 7, choose 3 should be 35. All right, so next term. You're going to do 3 raised to the 4th power, which is equal to 81. And then you have x to the 4th. Again, just make sure you distribute that everywhere. And then -2 cubed is -8. All right, so calculator, and you're going to simplify this. So make sure you take this very last step. And answer should be, it looks like -22,680 x to the 4th. All right. Everyone feeling fairly confident there? Okay, good. Because you can probably anticipate what you're going to see on your final. They're just like all these questions mixed up here. So whatever you don't get the first day, you're probably going to get the second day. So 11, write the equation of a line in slope-intercept form. So slope-intercept form is going to be y equals mx plus b. You guys know this from the past. Whose parametric equations are, so I have x equal to, and I've got -3t plus 7. And then second equation is y equals -t minus 10. So what you want to do with both of these is set them equal to t so that you can set them equal to each other. So on the left-hand side here, I'm going to go x minus 7. And then this is equal to -3t. And then divide by -3. And I'm actually just going to leave it like that because you're going to work with it anyways. So here's your first one. Then my second one, I'm going to add the 10 over. So we have y plus 10 equal to -t. And then I'm going to leave this as over -1. And then we're going to take both of these and set them equal to each other. So those are both equal to t there. I'll cross that off too. So next, coming up here, I have x minus 7 over the negative 3. And this is equal to y plus 10 over the negative 1. And cross multiply, solve for y equals. Oh, sorry, negative 1. So this is going to give me a negative x plus a 7 equal to a negative 3y minus 30. Again, just solve for y equals. So you're going to take your 30 over to the other side. So I have negative x plus 37 equal to negative 3y. And then you're going to keep going. So divide by negative 3 and divide by negative 3. All right, so your answer. We've got negative 1x divided by negative 3, so this would be positive 1/3 x minus 37 over 3. And then you're good to go. Again, no decimals with these. You want to leave everything exact. How's that type? Still okay? Perfect. All right, so number 12, you've got some trig content to do. And I hope these are getting better. Just keep practicing them. So what can we do with cosecant? How can you rewrite this? Cosecant is 1 over sine. Good. There is no simpler version of cos of x. So you're literally going to just go cos of x over 1. Now look at what you have to choose what's best for tangent. So if I look, I already have sine and cos. So can we write tangent using sine and cos? Yes, tangent is sine over cos. Did it make things better? Definitely. Actually, everything cancels, doesn't it? Cancels, cancels. Answer is just plain 1. Okay, those are getting better? Okay, good. And again, once you plug an identity in, if it doesn't improve your problem, then go back and see if there's something else you could use instead. All right, next one, formula sheet. Given the rectangular, switch this to polar. So you are currently x and y, and you want to conclude this with r and theta. And if you start with an ordered pair, then you need to end with an ordered pair. So that's how that answer is going to look. So on your formula sheet, you're going to find r. So r is equal to square root of x squared plus y squared. So r is equal to square root, and I'm going to go 4 squared and plus 4 radical 3 squared. You can absolutely try this and see if it works out nice first. So calculator, I think this does. So you have 4 radical 3 squared. Just make sure you're using parentheses to square these. You guys get 8. So r is equal to just plain 8. There's your first answer. I have 8 comma something. And then next I'm looking for theta. So you're going to plot this. And I have over 4 and then up 4 radical 3. So I'm first quadrant. Again, if you want to label this, you can. And then you're going to do inverse tan function to get your angle. So tan inverse of y divided by x. And that is equal to, is this 130 or 60? 60, thank you. So theta is equal to 60 degrees. You're going to go comma 60 and good to go. All right, how do we feel with 13, guys? Good? All right, perfect. Again, make sure you ask questions when you've got them. The review is entirely for you. So number 14, I guess I shouldn't have given you the word parabola just so you can identify it. So this one's a parabola because it has an x squared. Again, it's not going to have both. So what is this supposed to look like? Open up, down, left, or right? up and down. Good. Anytime you have x squared, it's either going to be this one or it's going to be this one. We just have to kind of work with it a little bit further to determine that. So first thing you want to do is write your equation in standard form. It's currently in general form. So standard form is going to require you to complete the square. So I need to start moving things over here. So I have x squared plus 4x is going to be equal to 12y minus 64. Now you're going to go and you're going to do completing the square. So I'm going to take this 4 right here, take half of it, and then square it. So that is equal to 4. So I get x squared plus 4x plus 4 equal to 12y minus 64 plus 4. Now the left-hand side is going to get factored. You can use all the space too. So this becomes x plus 2 squared equal to 12y minus 60. So what you want to get at with these is you want this to resemble the standard form equation for the parabola. So we want to make it look like this. And this is equal to 4p and y minus k. So we need to work with that side right there. So what you're going to do is take your GCF of 12 out. So I have x plus 2 squared equal to 12 y minus 5. So you're closer. Now from here, you're able to identify some of these characteristics. So it asked you to identify your vertex. All right, vertex is located where? Good, -2, +5. Awesome, and you can list that down below on your line here too. So first answer is -2, 5. -2, you're gonna need that anyways. Next thing we can determine is that p value. So I'm gonna solve 12 equal to 4p. So divide by 4, so 3 is equal to p. Therefore, my parabola is gonna open like this. So it's gonna open upwards. I'm gonna go over to my picture and then count up 3. So 1, 2, 3. And then 1, 2, 3 beneath it. And opens upwards, so you're gonna just make a little sketch here. And then your focus is always in the interior of your parabola and your directrix is beneath it because it never crosses over. All right, so here is my directrix. What's important with the directrix is it needs to be stated as an equation. So this needs to physically say y equals 2. It can't just say 2. So this one's y equals 2. Next, I have focus point. Where is that at? 5 must be 8, right? So we've got -2, 8. And then the last thing you need is the equation for the axis of symmetry. So you're going to go right down the middle of this. And once again, this must be listed as an equation. So this looks like it occurs at x equal to -2. So x equal to -2. Okay, how do you guys feel with the parabola? Pretty good? Again, you want to make sure you know that formula so that you can manipulate it and substitute in. So this formula right here, definitely make sure you know that one.
At this time, will all seniors in the upper A wing, the lower C wing, please proceed to the lower stadium field. Please sit on seat with blue tape.
Okay, so 15, find the 31st term of your sequence. So looking at your formula sheet, what type of sequence is this one? Arithmetic, good. Yep, so this is plus 3. Again, I think you'll find these type to be very easy. So this one's arithmetic. You're going to pull your explicit formula and just show your work here. So we have D equal to plus 3, where A sub 1 is equal to negative 7. And you're going to grab this formula. A sub 1 plus D, n minus 1. So I have A sub, I guess I'll write a general formula first, just in case you guys want it. So I'll do this first. So negative 7 and then plus 3, and then n minus 1, and then distribute. So we would have a 3n minus a 3. So a general formula, if you needed one for like your sigma notation, would be 3n minus 10 for this. And then lastly, we replace it with the 31st term. So A sub 31 is equal to 3 times 31 minus 10. All right, and minus 10, answer would be 83. So equal to 83. Okay. Guys, any questions on those so far? Okay, good. All right, 16, you're back to the trig stuff. Same thing with 17. Again, I wanted to give you a lot of these so that you kind of build your confidence with those. So given that sine of A is 3/5 and located in quadrant 1, so I'm immediately going to stop and draw the picture. So quadrant 1, and you're going to get this set up. So quadrant 1, here's A, and I have opposite over hypotenuse. And then Pythagorean theorem is going to get you your missing side. So you're going to go 3 squared plus b squared equals 5 squared. You do not have to show this. So b squared is equal to 16. Therefore, your missing leg is equal to 4. It's also a 3, 4, 5 right triangle too, so you could use that fact. All right, so now you're going to turn to your formula sheet and you're going to find the half angle formula for cos of A over 2. So A over 2, and are we going to use the positive or the negative for first quadrant? Positive, perfect. So I'm going to go plus and then square root. And I'm going to write the plus in the front, again, just so when you go to refer back, you know we did check for that. And then this is big square root of 1 plus, is it cos of A? These all kind of tend to look alike. So cos of A over 2. And then you're going to sub in. So this is equal to the square root of 1 plus cos of A is adjacent over hypotenuse 4/5. That's why you needed your picture. And then over 2. Don't type the square root. So just type your fraction here. So you have 1 plus the 4/5. And you're going to divide this by 2. Math, enter, enter. All right, did you guys get the square root of 9/10? So now you're going to split it. So square root of 9 over square root of 10. And I would like you to rationalize these, please, because these are fast to do. So this one is 3 over square root of 10. And you're going to conclude by multiplying numerator and denominator by the radical. Again, no decimals. These are exact value questions. So solution is 3 radical 10 over 10. And then done. You guys feeling comfortable with that one now? Good. All right, 17. Again, also a question that gave you difficulty yesterday. So you want to use sum and difference identities to find exact value of sine of 75. So I'm going to go through this again, just, so you get that reinforcement. When we have exact value, let's make a bank. What can we use for angles? 30. What else can we use? 45. What else? 60, 90, 180, 270, And now anything that reduces down to those values. So in quadrant 2, 180 minus 150 would give me that. In quadrant 2, so I would have 180 and then I would use 135 to get a 45. To get the 60, I could use 120. And now I'm going to be in quadrant 3. So quadrant 3, to get the 30, I would go 210 minus 180, 225 minus 180. And then next I would have 240 minus 180. All right, you got 3 more left. And again, this is your list. You're not going to have to use all of these, obviously. Now to get the 30 from the 4th quadrant, I would do 360 minus 330. Then I would do 360 minus 315. And then I would do 360 minus 300. Done. Okay, I hope from that list you can find 2 numbers that somehow add or subtract to 75. You guys see them? First 2, right? Okay. Again, I just wanted you to have that for the purpose of your notes. So how do we get 75? We take these 2 and add them together. So we're going to do the sine of 30 plus 45. So that means on your formula sheet, you need to find the formula that says the sine of x plus y. All right. So your formula for sine of x plus y is the first one in the 4th box. So this is sine x cos y. So we're going to go sine x cos y. And take your time copying these 2. We see a lot of student errors with copying formulas incorrect. And then plus cos x sine y, because they all look alike. So in our capacity, this is equal to the sine of 30, the cos of 45, plus the cos of 30 and the sine of 45. All right, you guys ready? What's the sine of 30? 1/2, good. What's the cos of 45? Very good. Remember, 45 is an isosceles triangle, so therefore, what's the sine of 45? Radical 2 over 2. All right, and then lastly, what's the cos of 30? Good. And if you've done a lot of these, you're going to notice all these answers pretty much look the same. So this side is going to give me a radical 2 over a 4. And then the other side is going to give me a radical 6 over 4. You can leave it like that if you'd like, or you can put them together. So radical 2 plus radical 6 over 4. Are you feeling more confidence with those now? Good. I knew you guys would. It was just, it's been so long since you had done them. But this is a list. So when you see those questions, again, I don't anticipate you would have to go that far, but that's what you can pick from. And the rules is you can only use 2 angles, addition or subtraction. All right, over to what, last page? Yes. All right, so number 18. This is a trig quadratic equation. And I have another one of these written out too if you want another one after this. So I have here 7 cos squared theta plus 5 equal to 2 sine theta. You have 2 different trig functions, we can't have that. So we need to substitute one of these. So what do you know something about? Do you know something about cos squared theta? Or do you know something about just sine of theta? Which one? Yep, cos squared theta is a Pythagorean identity. So this one is Pythagorean. That is your 3rd box down. Anytime it's squared. And we're going to replace it with, guys remember, 1 minus sine squared theta. And then plus 5 equal to 2 sine theta plus 7. Again, these are your questions that can yield a maximum of 4 answers. So now you're going to distribute. So I get a 7 minus a 7 sine squared theta plus 5 equal to 2 sine theta and then plus 7. All right, left-hand side, let's call that 12. So I have negative 7 sine squared theta, and then I'm going to go plus 12 equal to 2 sine theta plus 7. Okay, what do we need to get this equal to? 0. I would, if I were you, move the left side over to the right. So then you have a quadratic that has a positive a value. So move these two over here. So I'm going to get a positive 7 sine squared theta, if you add that over, and then plus a 2 sine theta. And then 7 minus 12 would give me a negative 5. All right, so at this point, it's kind of up to you. You can always check and see if this will follow AC factoring and work, and I believe it does. However, sometimes you want a strategy that works every single time, and that's quadratic formula. So what do you guys prefer here? Quadratic formula? Okay, I understand, because sometimes it's hard to do AC with these. Bless you. So I have A, B, and C. And for a couple minutes, you're just going to ignore the fact that you're working with a trig function. And I'm going to go x is equal to negative 2 plus and minus square root of 2 squared, and then minus 4 times A times C, and then all divided by 2 times A, which would be 14. So I have x equal to negative 2 plus and minus. And then you're going to grab this discriminant value. I don't know if someone has that yet or not. So 2 squared minus 4 times 7 times negative 5. We get 144. Nice perfect square. Again, that just means this would have factored. Now you keep going. So this is x equals negative 2 plus and minus 12 over 14. I'm going to split it off into both cases, and then we're going to put your trig function back in. So I'm going to have negative 2 plus 12 over 14. All right, so that would be 10 over 14. If you want to reduce it, you can. It doesn't really matter. I'll just go like this for now because you're going to put it in the calculator anyways. And then other sides, you're going to have negative 2 minus 12 over 14. So negative 14 over 14 is negative 1. Okay. Any problems down to that point? We're good? Okay, now you're going to go up and you're going to draw your two cases. So this is when your trig reappears. So now I'm going to finish and see if I have 4 answers to this or not. So I have a sine function. So I'm going to say sine of theta is equal to 10 over 14. And then on the other side, I'm going to go sine of theta equals negative 1. So the left-hand side first gives me a sine value that is positive. Quadrant 1 and quadrant 2. So in your calculators, you're going to type in second sine, excuse me, of 10 over 14. Did I specify rounding? I don't think so, right? We'll go a whole number again, that's fine. Second sine of 10 over 14 is like 46. So reference angle is 46, and that's actually your first answer. So then I'm going to go 180 minus 46, and that is equal to 134. So far, you know 2 solutions that are 46 and 134. Now you're going to hop over to the other side and finish this up. Sine of theta equals -1. Is this a triangle? It's not. What is this instead? This is unit circle. Anytime you get a value of 0, 1, or -1, you want to say unit circle and you want to type these in the calculator. So you're going to start and you're going to try some. So type in sine of 0. Does it work? No. Type in sine of 90. Does that one give me -1? Nope. Try again. So do sine of 180. Does that work? Nope. And then sine of 270. How about that one? You got it. Yep. So 270 degrees is going to be your final answer. I think that's the first time you've seen just 3. Again, it doesn't make the problem any different. Your unit circle, sometimes they give you 2, sometimes they just give you the 1. How are we feeling on 18? Okay. So next you have your potatoes. Formula sheet in front of you for sure. So with the potatoes, they are being launched from the roof of a 50-foot high school building. So H is equal to 50. Thank you. The first potato is launched with an initial velocity of 100 feet per second. So velocity is equal to 100. I also see mention of feet for this question, so that's important. At an angle of 79 degrees with the horizontal. Find the maximum height that the potato will reach. What does maximum height entail? Derivative, very good. So you're going to eventually need to do the derivative of your y equals equation. Okay, and then round your answers to nearest tenth of a foot. Okay, this question is in terms of feet. So we have a gravitational constant. You guys remember the number that went with feet? -32, perfect. That's the one you're going to need to know, okay? The 9.8, I know they use that a lot in science instead, but we tend to keep our units in feet. So definitely make sure you know the -32. Now you're going to go to your formula sheet, left-hand side, third box down. So I have y is equal to, and then you're going to go velocity. So we're going to go 100, because I like to put that in front, sine of your angle, which was 79, and we don't know t. And then plus 1/2, gravitational constant is -32, and we also do not know t squared. So that's off as well, but do you know the height? I think we did, 50. So h gets plugged in as 50. Next thing you're going to do is find, well, actually do one more step first. So 100 sine 79t minus 16t squared plus 50. And now you're going to do your derivative. So 100 sine 79. So just coefficient minus power down in front, 32t. Derivative of 50 is 0. So this is going to allow you to be able to solve for t. So I'm going to take that, add it over. 32t equal to 100 sine of 79, and then divide by 32. All right, so when is the maximum going to reach this height? So this is your time value. 100 sine of 79 and then divided by 32 is equal to like 3.06 and then some. So what do we got here? I guess let's go 3.07. That's fine, because again, your final, obviously you've got partial credit and you can, show all of that. So the last thing you're going to do, that is the time the maximum occurs at. So lastly, we go back and sub this in. So I'm going to sub into my y equals. So I'm now going to go 100 sine of 79 times 3.07 minus 16 times 3.07 squared and plus 50. All right, all that just goes in. And minus 16. Just be careful when you type. Final answer. Did you guys get 200.56? All right, and that is in feet. So the maximum height is reached at 200.56 feet. And that is going to be your answer there. Okay, are there questions on the projectile? Nope, the T dropped. Yep, it's always good question. It's always going to be the derivative of this is always just what's in front. So yep, you ignore your variable. And then this one, your power comes down in front. Yep, good question. Anything else on that one, guys? Yep. Oh, for this part?
Yeah.
No, for you guys, no. I would say go 2 decimals, or you could go 3. I have ranges for answers. So it's not like you're typing this into a computer now. I'm physically grading it, so it's okay. I would never round it to just 3 though. So take it, I would say take it at least 2 decimals. If you want to go further, that's fine too. Yep, I'll remind you guys of that on Wednesday as well. Anything else on that one? Okay, number 20, determine whether your series is going to be convergent or divergent. Justify your answer. These should look kind of familiar. So what are both of these? What type of series? Arithmetic, and arithmetic is always divergent. Yep. Those are both the same. All right, so now I'll kind of turn it over to you guys and see if there is anything else you may need or want. I've got a couple extra up here. I pulled a couple extra trig ones because I think, again, that's still the hardest place for you. Do you need anything more with like a simplifying trig expressions? Don't be shy. Yeah, sure. So I'll do this. I'll make this question 21. I'll make this 21. So what if we say to simplify and I'll go cos squared x plus cos squared x and tan squared x. And again, there's no equals on this one, so it's okay that you have the 2 different trig functions. Okay, what should we do with cosine? GCF, excellent. So this one's going to be a GCF. So you're going to take out cos squared x. And then what remains is 1 plus tan squared x. When you do these questions, make sure your reference sheet is right next to you and keep referring back to it. What can we do with 1 plus tan squared x? Yep, secant squared x. This is a Pythagorean identity because it's squared. So that gets the identity subbed in for it. So I have cos squared x. And then I have secant squared x. You're getting there. You're going to look at these and say, is there anything else we can do now? Do we know anything about secant? 1 over cosine, good. So you have cos squared x And then you have 1 over cos squared x. And does that help? Yep, so those cancel. And your resulting answer is just going to be 1. Okay. How are we feeling on that type? Better? Okay. The other couple I have up here, I have an exact value question if you guys would like that. Yes, no? Yes. All right, so this one's going to say find exact value. And then again, my recommendation is to go back and practice all of these problems again. So find exact value using sum and differences. So using sum and differences, that means formula sheet. And I want to go cos of 105. Let's make a list, but let's keep this one just to what we need. How about that? So my list for exact value, what can I pick from here? 30, what else? 45, what else? 60. So now take a look at your list. Have you already made it happen? Yep, right there. So how can you get a 105 out of this? Are we going to add them or subtract them? Add them, yep. So you're going to go cosine of 45 plus 60 or vice versa, it doesn't matter. And then on your formula sheet, you're going to find the formula that says cos of x plus y. So cos of x plus y is going to be cos x cos y. So this is equal to cos of 45 cos of 60. Is it plus in the middle? Nope, that one switches. Minus sine of 45 and sine of 60. Again, you want to be very careful when you copy these because they tend to all just blend together and look the same. Now you're going to plug them in. Okay, so again, what is the cosine of 45? Good. Radical 2 over 2. Next, what is the cos of 60? 1/2. Perfect. Minus the sine of 45 is square root of 2 over 2, and the sine of 60 is good. Radical 3 over 2. Make sure you're studying those this weekend. You can even do it outside. But it's going to be really hot. I think like over 90. So this is equal to, so radical 2 over 4 minus radical 6 over 4. So you may leave it like that, or you can take this one step further and go radical 2 minus radical 6 and then over the 4. Feeling good on that one? Yep, again, the recommendation is just keep practicing them. Go back through all those problems we just did today and yesterday and make sure you're really solid on those. Is there anything else you guys think you might want? Do you need another trig quadratic equation? Okay, so I'll give you this last one then. Now, I kind of just made this one up, so I don't know how well this is going to work, but it at least will kind of serve our purposes. What question was I on? 23. Okay, thank you. I guess it doesn't matter unless you're keeping track here. So let's go 6 sine squared and then x, and then minus 2 sine of x equal to cos squared x. Okay, so which one do you have to change here? Cos. Yep. Because the other ones are already signed, so there's no point in even trying to try something else for those. So when I have cos squared x, I'm going to replace this with? Perfect. 1 minus sine squared x. Then I have 6 sine squared x minus 2 sine of x. All right, so from here, this is quadratic. You want this equal to 0. So I'm going to take the right-hand side and shift it over to the left. Add that, subtract that. So you have 7 sine squared x and minus 2 sine of x and minus 1 equal to 0. Okay, there's no way that this one is going to factor. There's no way numbers would multiply to 7 and add to 2. So you have to do quadratic formula here. So we're going to go A, B, and C. Again, I'm hoping that this does work. So we have x is equal to negative negative 2, so 2 plus or minus square root of 2 squared minus 4 times A times C, and then all over 2 times A, which is 14. So x is equal to 2 plus or minus square root of 4, and then we have plus the 28 here. So I have 32 over 14. You don't need to break down the radical unless you'd like to. I don't know, it's up to you guys. But now you're going to break this off into your 2 cases. So I'm going to pull my sign back now, and I'm going to say that sine of x is equal to 2 plus the square root of 32 over 14. So this is clearly positive. So this is going to be a triangle in quadrant 1 and 2. And you're going to do second sign of that really careful. So be really careful with parentheses. You're going to go 2 plus square root of 32 and then divided by 14. I'm going to round this nearest whole integer again. I'm going to call this 33. So first answer is 33, and then your second answer here would be 147. How's that side, okay? All right, now you're going to try your next one. I need to see what this is though. So what is 2 minus the square root of 32 over 14? Is this positive or negative? Yeah, I was going to say, I think it's negative. So then you're going to place this where sign is negative instead. So we're going here and we're going here. So you're going to go second sign of whatever that decimal was with a positive. I'm going to go 2 minus the square root of 32 and then divided by 14. So I'm going to go second sign of 0.2612038, we'll say. And I got an angle measure of like 15. So the last thing you're going to do is 180 plus 360 minus. So 180 plus 15 would give me an answer of 195. And then lastly, 360 minus 15 would give me an answer of 345. So that one had 4. All right, how are we feeling on those? Pretty good? Okay, so now I'm going to kind of leave it up to you guys. So you've had, oh my gosh, what, like 3.5 weeks of review. You have all those sheets in the packet. You can absolutely go back and redo. This sheet too, the day 8 stuff, 7 and 6. Those you're welcome to redo as well. Do you guys have questions for when you come in next Wednesday? When you come in next Wednesday, your test will be on your desk. Start it as soon as you come in because I want to give you, again, the full hour on the first day, full hour on the second day, because that's what you typically would have gotten. Calculator can be used, formula sheet can be used. Part 1 must be finished prior to you leaving on Wednesday. Sure. But not like 5 in the morning, okay? Yes. I don't know yet. We'll see if everybody is here Wednesday, Thursday, and plan it from there. And then we'll see what the weather does. It's always kind of the wild card there too.